Alright guys, well guess what happened? One of the Kangaroo boards, the last one that I did, and I think that this video board actually went with the really jacked up CPU board. This thing has sprung a leak. It quit. If I turn it on, I'll show you what it's doing. And I've got the board I got the boards flipped around so that I have access to this board. And I did Swaparooskies, so I know that it's this board. It's not the CPU board. This board's the problem. It acts like a CPU board. It's just dead. It's just got kind of a cross. I came out after the third hour, after hour number 3 of my test. I came out to the shop and opened the door and was greeted to this. I was like, ah, boy, that does not look like Kangaroo. Something is amiss. So like I said, I did some Swaparooski, and I determined that the video board is what failed. So, and it was nice to have a working set here to do that with, just to do a quick swap, because it looks like a CPU board issue. I actually put the fluke on it, and I could read my ROMs and do the RAM tests and everything, so I was like, well, it doesn't look like it's this board. So, yeah, we're going to have to, I mean, this video board just kills the whole thing. It'll kill the whole board, which is pretty unfortunate. I did print the video schematics if needed, but first thing I'm doing is just kind of poking around, and I already started, and you can see I have a red dot right here. This thing has a whole slew of these Fujitsu parts on them, and they are notorious for failing. This thing has 32, 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8 is 32. 32 4116 RAM on them. A la Zookeeper. You know, it's like the Zookeeper set a lot. With the way that, you know, it's got 32 soldered into the board, 4116 RAMs. What a pain in the butt. And you cannot, with the fluke, test these, which is unfortunate. So I went through and probed all of the data in and data out pins, and there's no data coming out of these at all. There's no write signal going to these at all. So this thing's just not doing anything. And I came to this guy, and I'll show you what this chip looked like. We have on this pin here, we have a flashing signal. Now, I don't know what these signals look like, so I'm actually want to look this chip up on the schematic. And here's the other, and then your output is nothing. There's no output. So, I mean, if anything, at least this should be a low output, if anything. And here you have a high and a high and a high. That's right. Over here we have a low, and a float. A low, and another float. So I want to look this chip up, IC20, because it's very, very suspect. So I'm going to look that guy up on the schematic and see what's going on. It's an AND gate. Yeah. Let's look that up and see if it's something to be alarmed about. Okay, open the first page. Clock, sync chain, and timing signals. In our IC20 right here, load shift signal is pin 8, which is floating. So that's no good. That could be our whole problem. I mean, I just opened this thing up and started probing around. But that is the gate that we were looking at that has the floating output. So, yeah. Load, is that shift? Yeah, that's shift. Load shift, I believe. So, yeah. Interesting. Okay. Ah, there's another. That was a floating signal right there. 4 and 5 out to 6. Let's look at that one again. And that's an interrupt signal for the CPU right there. Yeah. Let's check 4 and 5 out to 6 on that guy. Here's 4, which is 0. 5, which is a 0. So this should be 0. And it's floating. This thing has just quit. That thing said enough is enough. And since the outputs are floating and they're not like pegged high or pegged low, I should be able to jump an 08 over that and this thing should come to life. So let's do that. Okay, got the 08 jumped over that chip. Piggybacked. And there's our Kangaroo back. All right. Well, let's go ahead and replace that proper and let this thing run for a couple more hours. We will go ahead and let me go ahead and replace that, and then we'll be back. All right, and we have our new chip installed in the board. IC20 replaced. So we'll go ahead and put this stack back together and start another runtime. Go a couple hours. All right, we are back together. I put good standoffs instead of those chintzy ones where the boards just aren't stable. Some good standoffs on here. Our video board is repaired again, or for the first time actually. And we are running. Again. So I will see you back. It is, what time is it? It is 2:24. And I'll come back around 4:30. If it's still running at 4:30, we're calling it good. That'll be after dinner. We're making tacos. I got my brother and my dad coming over. We're going to have some good tacos. So we'll see you in a couple hours. Hopefully put this one away once and for all. Okay. We'll see you. All right. And here we are. It is 4:56. 2.5 hours. And we are still rolling. All right. So that makes 5.5 hours for this board set. And we had one chip fail in that 5.5 hours, and that was that 08 that I replaced. So we'll go ahead and make sure our sound is still working. Coin up. Yeah. It's all working. So that's going to do it for this one. And after 2.5 hours, we're going to shut it off. And as always, thanks for watching. And yeah, now these two boards are done now. So we will see you all on the next Classic Arcade Repairs. Stay tuned because I have a death race coming up at some point, which will be pretty awesome. All right, we'll see you next time. Bye for now.